In this video, we will talk about how to solve equations using addition and subtraction. The first two examples we see, we're going to use addition or subtraction, but use simple numbers or only use positives. The first one we see is x plus 16 is equal to 32. To show the inverse operation, I'm going to show the opposite of plus 16. So I'm going to show minus 16 to both sides. Whatever I do to one side of the equation, I will also have to do to the other. The reason I'm showing this is because I want to make sure x can be by itself. So when I show the inverse operation, a positive 16 and a negative 16 are able to cancel out, and that's just what I wanted. But then 32 minus 16 is going to give me 16. So my answer is x equals 16. The second one, I have x minus 17 is equal to 35. So to show the inverse operation, I need to show the opposite of minus 17. That's what I want to get rid of to get x by itself. To show the opposite of minus 17, I will need to show plus 17 on both sides. When I do a plus 17 to a negative 17, those cancel out and give me 0. So all that's left is x here. And then 35 plus 17, if I just add, I know 5 plus 7 is 12. Carry that extra 1. 3 plus 1 is 4, plus another one is 52. So x is equal to 52. In these two examples, I'm seeing how to solve equations with addition and subtraction, but using negatives. So I do have to be a little bit more cautious here. I'm still going to show the inverse operation. So I see x plus 16 is equal to negative 32. The opposite of a plus 16 is a minus 16. So I'm going to show minus 16 to both sides. Here's where the tricky part happens. The plus 16 minus 16 will cancel out, so all that's left is x. But when you see these two things happening over here, the minus 32 and a negative 16, so these are both negatives, these are technically same signs. And what we learned before is when we have same signs, we are going to add them and keep the same sign. So it's like a negative 32 and a negative 16 put together. 2 plus 6 is 8. 3 plus 1 is 4. So my answer, I'm actually going to get x is equal to negative 48. So we do have to be careful here. So if we're looking for same signs, we will add. The second example, we will still show inverse operations, but we're going to see a little bit of subtraction to solve for it. I see x minus 17 is equal to negative 35. So the opposite of minus 17 is plus 17. So I'm going to show that to both sides of my equation. Minus 17 plus 17 cancels out, so all that's left is x. Then I notice I have a negative 35 and a positive 17. These are different signs. And when we talked about before, different signs means to subtract. So I'm going to subtract 35 and 17. Can't do 5 minus 7, so I'm going to borrow. That becomes a 2, so 5 can become a 15. 15 minus 7 is 8, and 2 minus 1 is 1. And then I just keep the sign of the larger value, which is a negative. So the answer for this one is negative 18.